So this is the last chapter of the opening round of the unit circle, and this is reciprocal trigonometric identities. Remember, reciprocal is when we flip the fraction, or technically take the multiplicative inverse. Okay, so straight to definitions. The definitions are the secant of an angle, right? We get more words here. The secant of an angle is the reciprocal of the cosine of the angle. The cosecant of an angle is the reciprocal of the sine. The cotangent of an angle is a reciprocal of the, tangent of an angle. And if you think about it, that makes sense. The cotangent can also be thought as the ratio of the cosine to the sine. Remember, tangent is the sine over the cosine. Well, the cotangent would then be the reciprocal of the sine over the cosine. I'll write this all out. Now, when you're finding these, you're going to end up with a lot of irrational numbers. So you want to make sure that you rationalize your results. Okay. So these are the definitions. Let me just sum those up for you. So you've got something called the secant, which is abbreviated secant, S-E-C, is equal to the reciprocal of the cosine, right? The cosecant, abbreviated CSC, is the reciprocal of the sine, and the cotangent, COT, right? COT, COS, they're close, but they're different, right? Is equal to the reciprocal of the tangent. It's also equal to the cosine over the sine. Now, in terms of coordinates, that means that this is 1 over the x, this is 1 over the y, and this would be x over y, okay? Because remember, we have the cosine, which is equal to the x, the sine, which is equal to the y, and the tangent, which is equal to the sine over the cosine, or the y over the x. All right, a couple of notes. Cosine, no co. No co, cosecant. Tangent, cotangent. So when you're pairing these off, pair off the co with the no co identities. Secant means it must have a co, so cosine. Now, about 10 out of 10 people pair up the cotangent and the tangent because, well, they both have tangent in them, all right? But the co versus the no co is the one way to keep these sorted out. So you can tell cosecant, oh, that's related to the sine. So let's jump right in. If you were to find the secant of 30 degrees, secant, it has no co, so it would be the cosine. So you'd look at the x coordinate and take the reciprocal. So you take the x coordinate, which is the square root of 3 over 2. So technically you write that as 1 over root 3 over 2. But you could just go straight to flipping it, which would be 2 over root 3. Now, unfortunately, you're going to have to rationalize that. So that would be 2 root 3 over 3. Secant related to the cosine, aka the reciprocal of the x value. So you can either write it like this or you just flip it. In this case, we had to rationalize it. Now, that would mean if you're asked to find the cosecant, let's say of 45 degrees. Cosecant is related to the sine, so you're looking for the y coordinate, and we can just take the reciprocal, which does mean we're going to have to rationalize. So we get 2 square root of 2 over 2. The 2's cancel out, so we just get square root of 2 as our answer. All right. So a lot of this has to do with rationalizing things. In some cases, if you're finding the cotangent, let's go a little bit. So let's go crazy. Let's go with the cotangent of 120 degrees, right? So the cotangent is equal to so there's 2 ways to go. Either you find the tangent, which means you have to divide and rationalize, and then you flip it, which might mean you need to rationalize again. Or you can go straight to, well, the cotangent would be the cosine over the sine, or the x over the y, right? So you do negative 1/2 over square root of 3 over 2. So there's 2 ways to go with this. When you're looking at this, maybe you remember, oh, when I divided like that, right, I ended up in the end with the square root of 3 over 3, but it was negative. So if you happen to remember that, great. If you don't, then you still have to change it to multiplying by the reciprocal, which is going to be negative 1 over the square root of 3, because those will cancel out. And you're still going to have to rationalize. You still end up in the same spot, okay? So in spite of all this, because the cotangent is just the reciprocal of tangent, you're still going to have a certain number of values you're going to get. So negative root 3 over 3, or some variation of root 3 over 3, plain old root 3, square root of 3, right? Or 1. And sometimes it'll be undefined, and sometimes it'll be 0. So if you're looking at the cotangent of, say, 90, which is x over y, it'd be 0 over 1, which is just 0, versus the cotangent of 180, which would be equal to negative 1 over 0, which is undefined, okay? So let's take a look at some more examples, just because this requires a little bit of thinking on some people's parts, most people's parts, because you have to sort out what's going on with each one. So if I wanted to find the secant of 270, I know that secant is related to the cosine, so it's the reciprocal of the x. What is the reciprocal of 0? It is 1 over 0, which is undefined. Well, that's new. So that does happen, so be aware of that. On these certain cardinal points, right, 0, 90, 180, 270, you may end up with angles that end up having undefined secants or cosecants, okay? Also, I'm finding the cosecant, so I know that's going to be 1 over the y value, the reciprocal of the y value, reciprocal of the sine. Let's say it's the cosecant of, let's go with 450 degrees. So I know that the cosecant of 450 is the same as the cosecant of, because it's more than 360, I subtract 360, 90. So the cosecant is the sine. So what's the reciprocal of 1? It's just 1. Okay, so that wasn't too terrible, actually. So what if we were asked to find the secant of negative 60 degrees? So if I had 360, I would get the secant of 300. In other words, because this is secant, that means it's related to the x, so it would be 1 over the square root of 3 over 2, the x, right? Or 2 over the square root of 3, but I have to rationalize, which is, now if you're doing this right, you're going to get a lot of practice rationalizing, and it'll become second nature. And that's kind of the point here. Good practice, okay? So 2 root 3 over 3, okay? So I think that's enough examples, but basically all you're doing is identifying, if you're looking at secant, that means it's related to the cosine, so the x value, but it's a reciprocal, all right? So if you commit these to memory, it's not that bad. Cosecant, secant are a pair, sine and cosecant are a pair. Notice the lack of co and the co, right? Tangent and cotangent, and they're just reciprocals. So if you remember one and know that the others are the reciprocals, that is flipped, might save you a little bit of work.